right, today we're going to talk about 1.5 absolute value equations. This is our last section in Unit 1. Absolute value just refers to distance. For instance, the absolute value of x equals 2. Absolute value we just show by these two bars. The absolute value of x equals 2 means the distance of x away from 0 is 2. So that means it could be over here at positive 2, or it could be 2 away in this direction, which would put it at negative 2. So we say x is equal to positive 2, or we consider the negative version, x is equal to negative 2. Okay, so let's look at an application here. It says in 2007, a telephone poll was conducted to determine the reading habits of people in the U.S. People in this survey were allowed to select more than one type of book. The survey has a margin of error of plus or minus 3. The margin of error just means that the result could be 3 points higher or 3 points lower. So the percent of people who read religious materials could be as high as 69, adding 3, or as low as 63%, subtracting 3. How would you represent this margin of error in the percent of people who chose religious books with an absolute value equation? So it's always going to be set up the same. We're going to have the absolute value of the actual value minus the average. So how far away it can be, the distance, is equal to the margin of error. Oh, M-A-R-G-I-N of error. All right, so in this case, we're going to have the absolute value of the actual value is usually what we're looking for. We don't know what the percent is, so we'll just call it P. Minus the average, we know the average, that was the 66, is equal to our margin of error. So in this case, it's 3. Okay, so there's our equation. To solve that equation, we would say, okay, whatever's inside here, it could have been positive 3, or it could have been negative 3, because we're just talking about distance. So we're going to have P minus 66, and P equals 3, and P minus 66 equals negative 3. Because when you take the absolute value, it's always going to be positive. We're talking about distance. So I'm going to add the 66 over, and I get P equals 69. Here I'm going to add it over, and I get P equals 63, which are the two values that we already have. It says the distance between 63 and 66 on the number line is the same as the distance between the should say 66 and 69. Okay, these two distances are the same. It's 3 in either direction, which is what the margin of error represents, how far it is in either direction from the average. Okay. All right, let's take a look at the next one. All right, so here we have just the absolute value of f plus 5 equals 17. So we're going to split this up into the positive case and the negative case. So I have f plus 5 equals positive 17, or that could have been f plus 5 equals negative 17. Okay, to solve this, here I'd subtract 5, which would give me f equals 12. But we're going to have two answers. We have what if everything in here was positive, or what if everything in here was negative. So over here, I'm going to subtract 5 and get f equals negative 22. All right, coming down here, it says, can the absolute value of a number ever be negative? So what's over here in this case is negative. Remember, absolute value is the distance. Our distance can't be negative. You would never say, I went negative 3 feet. It doesn't make any sense. Distance cannot be negative. So this is just no solution. Okay, can't have a negative on this side if the absolute value bars are alone on this side. Okay, so that's what this little guy up here is telling us. It says the absolute value won't put up with negativity. So the absolute value of a negative is positive. This number is always going to be positive. Okay, it says put any value but 0 behind bars, and the result will always be absolutely positive. This has to be positive. So it's negative, no solution. We move on. So looking at another one. Another example over here, and I have 2x minus 1 equals 7. And once again, we're going to split it up into the positive case and the negative case. So I have 2x minus 1 equals 7, or that it equals negative 7. On this side, I'm going to add 1, because remember, you take care of whatever's not clinging to the x first. So take care of the addition and subtraction first. Add 1, we get 2x equals 8. This is multiplication, so to undo multiplication, we divide. Dividing both sides by 2, I get x equals 4. That's one answer. Then I have to come over and find the other. So here I'm going to add 1 over. And I get 2x equals negative 6. This is touching my multiplication, so I divide by 2, and I get x equals, get this out of our way, negative 3. So remember, a negative divided by a positive is a negative. There we go, and there are my 2 answers. Now let's look at another word problem. It says the average January temperature is 1 degree, okay, in a northern Canadian city. The actual January temperature for that city may be about 5 degrees Fahrenheit warmer or colder. So because it could be that much warmer or colder, that's how much away from it could be. That's my margin of error. It says write and solve an equation to find the maximum and minimum temperatures. So once again, I'm going to set it up. Absolute value of the actual minus the average. So here, the actual is what we're looking for. Let's just call it T for temperature, minus the average here is 1 degree. And it's always equal to how far away from it can be, how far of a distance it can have, which is our margin of error, 5. Okay, so to solve this, we split it up into our 2 cases. So we have the positive case. So we wrote the equation, now we're solving it. Positive case and negative case. So I have T minus 1 equals positive 5, or T minus 1 equals negative 5. And here, let's move this down out of our way. Okay, so for this one, I'm going to add 1 over to get T by itself. So I have T equals 6. That's one answer. It could be 6 degrees. And then here I'm going to add 1 over. And I get T equals negative 4. So there are my 2 answers. And we can go back and make sure that makes sense. So if we started at 1 degree and it could be 5 warmer would be 6. If it's 1 degree and it could be 5 colder, that would be negative 4. So that makes sense. And I would just say, max of 6 degrees Fahrenheit and a minimum of negative 4 degrees Fahrenheit. So we always have to make sure we answer a question with a label. We were talking about degrees here. So there's my final answer. All right, and this last little example down here, I want to take a look at. Sometimes you have other things on the same side as the absolute value. The only trick to that is you just have to move everything else away from the absolute value before you split it up. So it's still just your opposite operations. Here I have 2 times the absolute value of all this stuff. Well, to undo multiplication, we just divide. So we're just going to do opposite operations to get the absolute value bars completely by itself. So here I'm going to divide by 2, and I get the absolute value of negative 2y plus 6 equals 3. And then I still split it into my two cases. So I have the positive, and I have the negative case. Positive would be negative 2y plus 6 equals 3. Negative would be negative 2y plus 6 equals negative 3. Okay, so here, start with this piece, subtract the 6 over. Nope, I don't know why I wrote plus. That should be a minus. And we have negative 2y equals negative 3. And then divide by negative 2 to get y by itself. I get y equals, I can just reduce this down to just 3 halves because a negative divided by a negative is a positive. Or you could write 1.5, that's fine too. So that's one answer, is 3 halves. Okay. The other answer, I'm going to subtract 6. I get negative 2y equals negative 9. Divide both sides by negative 2. And I can write y equals 9 halves. You can leave that as a fraction or change it to a decimal. Either way, it's the same number. And we have our two answers. All right. And that is the end of section 1.5. Please let me know if I can help you out with this material in any way.